So you might have heard about these new things called neural networks lately, and if you go on Google and you look up what a neural network is, you're probably going to see a lot of pictures like this. You're probably going to see these pictures that show these sort of layers of neurons, and then in between them you have these axons, or these sort of connections. So the idea is that you put some signal into your neural network, and then when that signal is finished going through the neural network, you're going to have some kind of output. So you might have something like, I'll give you an example that's a little more intuitive. You might have something like this, where you give the network a picture of a dog or a cat, and the network's going to look at that picture and it's going to crunch it, it's going to do some crazy mathematics, it's going to filter down, sort of cascade down through these neurons, and then at the end it's going to say, hey, that was a dog, or hey, that was a cat. So this is kind of the image we have in mind of neural networks. When I first started learning them, one thing I found a little odd is the fact that this hierarchy exists. And I also found it strange that these nodes, you have sort of these preset nodes. When I was imagining a baby being born, I wouldn't expect there to be this very sort of discrete system of layers, and also I found it odd that there would be a discrete system of nodes. So for example, a baby certainly doesn't have the idea of what a cat, dog, fish, and horse are when he's born, and if he did, it would cause problems if he wanted to learn a new animal. So to me it was a great model, but it was a little too solid, a little too immutable. So I've been playing around and making some cool code. I sort of threw this together the other night, and I thought it might be kind of cool to look at a little. I'm sure this has been done before, and let me boot it up because it takes a second to initialize. So yeah, I'm sure this has been done before. I'm not an expert in the field, but I also want to add that the standard model of neural networks is great, and it does amazing things, and I'm not trying to sort of usurp the ubiquity of the current neural network system, but just suggest one that's maybe a little more malleable. So what I'm going to do is I'm going to initiate, and it should pop up any second now, I'm going to initiate 5,000 neurons. So here, that's what I've done. Here I have 5,000 neurons that I've just initiated. So each of these dots is a neuron. It can be activated, and when it gets activated, you'll see the color and the size of it will change a little. I've also put between here connections, so axons between them, which I haven't shown because it gets too messy, but these are connected to the neurons they neighbor. The axons can be strong or weak. A strong axon between two neurons means the signal will be very, very efficiently transmitted. A weaker one means it'll be transmitted less efficiently. Also, axons can only be so long. You can't have one stretching across the entire brain. Let's say this is a pseudo brain. So I'm going to go ahead and activate some. So I've activated about 50, I think 50 or so of those neurons. And now you'll see they very quickly spread out. They very quickly activate their neighbors, and it causes a big cascade. So imagine, if you will, what we've just done is we fed an image of a cat to a kid who just opened his eyes for the first time. So his mind is completely new to this, and his mind is seeing a cat for the very, very first time. So this is sort of the image I want you to keep in mind, which is kind of funny because that's what we're doing. All right, so it cascades through. It's going to continue through the kid's mind and slowly die down as it spreads out a little. Now, one thing I want to add is that I've given this mind one interesting ability. When a strong electrical signal traverses an axon, it's going to strengthen that axon a little and make it conduct even better. When a weak electrical signal goes across an axon, it's going to make it a little weaker. And if no signal at all goes across, nothing changes. So that will sort of give the brain an ability to adjust itself. Okay, so now let's try another. So now I'm going to give the kid a picture of a dog. So that was cat. So for the very first time, the kid is seeing a dog. And again, these are randomly scattered because the kid doesn't know what it's looking at. Its brain hasn't had the time to really learn its surroundings. So again, I've just randomly scattered these. And again, they're going to cascade through. They're going to cascade through with a different pattern. So here's some kind of different pattern. It's getting quite bright up here. We're going to continue through. Okay, so now the kid, his brain has seen a cat and a dog, and the neurons have lit up, the signal has gone through the brain, and the axons have all been adjusted. So now let's see what happens if again the kid sees a cat. So I'm showing the kid the same one. This is activation 1, that's cat. So same places are being activated. All the same receptors are being activated as before. One thing you'll see is that it's a little different this time because the axons have been adjusted. And very, very quickly, it gets to where it was before. You have this sort of big burst and then it's quickly finished. Let's show them the picture of a dog again. So here's dog. So this is the dog activation again. And you'll see now, because the brain has adjusted very, very quickly, you see in 2 steps, it was just really like the 3rd step, you already have the concept here. It's gotten to this area of the brain, and it just went bang, and it was there very fast. So there, it just slowly dies now. Now, here's an interesting part. What if we show the kid something he hasn't seen before? So now I'm going to show him a different input. So let's say this is an input for a fish, which the kid hasn't seen before. Now something a little different is going to happen this time. You're going to see that it takes longer. It kind of spreads out. You still have some pockets here. It's randomly initiated, so you don't see it as clearly in this randomization. Sometimes it's very, very clear. But you see, it takes a while for it to really settle. It's only by step 5 here. So before, by step 3, when you showed it cat and dog and it had already seen them, it was very, very quickly in the areas. But for something it hasn't seen, it takes a little longer to get there. So that's the end of this demo. But the reason I like this model is because you start with nothing. You don't start with sort of a preset for a neural network with certain layers and certain axons. I've given the kid nothing to work with. I've randomly assigned the position of all these. I've also randomly assigned the axon strengths. But you can see there's a subtle difference when the kid looks at something that he's seen before and something he hasn't. In addition, each time something new is introduced, the brain has a way of sort of setting pathways and building a random pathway that the kid can then use to know that it's seen this thing before. It's the idea of how can you know if you've seen an object before or not, and how does the mind change when it has seen an object for the first time. So that's the end of that. This is sort of the demo I wanted to just show off a little. One other thing I'll note is this is really variable code, and the number of neurons, the number of time steps I'm taking are variable, but some much more imperative ones. For example, the coverage is how far those axons can reach. Also, how many am I going to activate at the beginning? Also, how quickly will they attenuate? And I have this very interesting alpha parameter, which is how quickly will those axons change strength. So how sensitive are they to different electrical signals going across them? So what I'd like to stress is these are all really, like, I've been playing with them, but I haven't had millions of years of evolution to do it. So babies are kind of cheating on that front. But I think realistically, this is something I'd like people to play with a little more and explore a little more. I'm not an expert again, but I think if you really, really tweak these parameters and you have a strong enough computer, I think there's a possibility this could be a really, really good neural network model that could maybe be a little more malleable than what we're doing at present. And again, someone's probably already done this, but I thought it'd be fun to show just in case anyone out there finds it cool. There's going to be a link to this code in the GitHub, and you don't have to credit me. You go have fun and build a cool new neural network that will teach babies about what horses are, or whatever, and robot revolution and such. Bye-bye.